Next on the list here, we have trig functions and parentheses. And this is really just all about notation here, okay? It ends up that there are times where with our trig functions, we just leave the parentheses out, okay? And there are times where we can't leave them out, okay? And so we're going to figure out what those situations really are, okay? So this says you may leave out the parentheses in a trig function if there are only products or quotients, okay? So for instance, if we have, say, sine of, let's say, 3x. You can write this without parentheses. You can just say 3x, okay? The only downside to not writing in the parentheses is at this point, it's really easy for students to forget that sine, cosine, tangent, these are all functions, okay? And I suppose the students don't forget that they're functions, but they forget that 3x is the input, okay? That 3x is being plugged into the function. So it's not a bad idea to get used to just writing those parentheses in there, okay? I do from time to time get lazy and don't write them in, okay? So let's see here. Another thing I said was quotients. So yeah, you could have something like cosine of, how about 5 pi over 6? Okay, you can write that without parentheses. Okay. It's as soon as you have any addition or subtraction that we need to write these parentheses in here. So for instance, if I had sine of 3 plus x, I may not write this as sine of 3 plus x, okay? Is what this technically says right here is sine of 3 plus x, which is far from what we want it to say if we were trying to write sine of 3 plus x, okay? And next, let's do one with cosine, I suppose. And if we had a difference, so how about cosine of x minus pi over 2? Again, I may not write this without parentheses, okay? And this is actually important to remember because when you do get into your calculus classes, depending on what book you're using or what teacher you have, you're going to see those parentheses there sometimes, and you're going to see them not, and you need to know what it means when those parentheses are there and when they're not there. All right, and so the next little bit of this video, we're really going to be thinking about sine and cosine in a way that would be much easier if we were thinking about it graphically. And we're going to go ahead and think about sine and cosine graphically a little bit here anyway. Okay. So let's start off with just thinking about the cosine function. You've all seen the, well, have we seen the graph yet? Maybe not. We'll see it here in a minute. Okay. Let's just think about the domain though. So cosine, the inputs are angles, and same with sine, right? We plug in theta, an angle. Okay. So it doesn't matter how big that angle is, and it doesn't matter how small it is, right? It could be cosine of minus a million, or cosine of 5 billion times pi. Okay. So we can actually plug in any angle, so the domain is actually all real numbers, or minus infinity to infinity. And same with sine, any angle. But now I want you to think about this. What is the range for each one of these functions? Okay. What's the maximum output and what's the minimum output for these functions. Now that you've thought about it for a minute, let's start off with cosine. Okay, so cosine is the x value here, right? So we want to figure out, well, what's the smallest x value we see on here? Okay. Well, it is -1. Okay, that is the smallest output for cosine of an angle. And then the biggest output for cosine of an angle is +1. And the same exact thing could be said about sine. On to periodic functions. And it actually ends up that all of our trig functions are what is called periodic. I'm going to write down the mathematical definition, but I think we'll get a much better idea of what periodic is when we look at it graphically. So mathematically, a function f is periodic if there exists a positive number p such that f of t plus p is equal to f of t. Okay, so in other words, adding this special number essentially has no impact on the output. Okay, and the smallest number p for which f is periodic is called the period. So let's take a look at cosine and sine and see what it is that makes them periodic. Okay, so is what makes a graph periodic is if you have a pattern that keeps repeating. Okay, and you can see I've went red, blue for cosine, and all of these red and blue pieces are exactly the same. They look exactly the same. And this pattern happens to repeat every 2 pi. And actually the same thing could be said about sine over here. So the same shape is repeating every 2 pi. So both sine and cosine have a period of 2 pi, which I've apparently already written in here. Okay. All right, and what we're going to do though now is, now that we know that the period is 2 pi, we're going to write it in terms of our definition of periodic up here. Okay. And so here's what I mean. Let's see. There we go. So what I mean is cosine of t plus 2 pi k and sine of t plus 2 pi k are just equal to, well, the top one's equal to cosine of t, and this one's equal to sine of t. And you might see that word that we mentioned recently, integer. So just remember that the integers are the whole numbers and their opposites. And let's kind of test this out or try to understand it. So if we were to maybe look at the graph of sine here, and we're at sine of -2 pi at the moment, you can see it's 0, right? Okay. Well, if we were to take -2 pi and add the period to it, we'd get sine of 0, which also happens to be 0. But we could have also added a different multiple of 2 pi. We could have maybe added 2 pi's. And if we did that, that would give us sine of 2 pi. And if you look at the graph again, sine of 2 pi is also 0. So no matter what number I actually wrote here, that's why we have k written over here. Okay, because no matter what k I use here, this is going to keep being 0. Okay. Let's go ahead now and take a look at the periods of tangent and cotangent, and then secant and cosecant. Okay. Graphically, I want you to look and tell me how often or how long it takes for tangent to repeat its pattern, and same for cotangent. And hopefully the number that you've come up with here is pi. It takes pi radians for it to complete its period. And so what that would mean is not sine this time. How about tangent? Tangent of t plus pi. And we don't have to just do pi. We could do a multiple of pi. Should be equal to tangent of t. And we can say the exact same thing about cotangent. T plus k pi is equal to cotangent. And one more. Secant here. Secant and cosecant. And now, again, I want you to look at this for a minute and try to determine how long it's taking to repeat its pattern. All right, let's see what you got. Oftentimes, students will say pi here because of those, those vertical asymptotes. It kind of reminds them of tangent and cotangent up above. But it actually ends up, the pattern here is kind of one of these upward facing U's and one of these downward facing U's. They're not really U's, but hopefully you get what I'm saying here. It's the two of them combined that makes one period. And so that's going to be 2 pi radians if we look at this picture. So 2 pi. And so then secant of t plus 2 pi k is equal to secant of t, and cosecant of t plus 2 pi k is equal to cosecant of t. And now we're on to our last page.